This is Jumpstart your iOS app with the toolkit. If that's not what you're here for, you're in the wrong spot. There's another session right at 6, so I'm going to kind of breeze through this, 20-25 minutes. If you have further questions, hopefully there'll be a little time after this, or I'll be at the island probably till 6:30 and then most of the day tomorrow. So you can either ask me or anybody else at the island. My name is Mark Dostal. I'm a developer on the iOS Runtime SDK team. What we're going to talk about is a quick overview of the toolkit, and then how you can use the toolkit, how you can add toolkit components to your mapping app. It's essentially the toolkit is essentially a set of components that allow you to add GIS mapping functionality easily without you having to write them yourself. It is a public GitHub repo, so the source code is available. There's documentation and examples. We currently have 5 components: compass, scale bar, a toolbar, legend, and a job manager. The job manager is fairly complex. I hope we'll get to that one, but if not, you can always check the documentation online or come hit me up over in the showcase. Also, the toolkit components are cross-platform, meaning we support them on pretty much every runtime platform. There may be some differences in which toolkit components are available, but in general, they're gonna look the same, act the same, kind of just like the Runtime SDK itself. There's a couple ways to get the toolkit. You can use CocoaPods, or you can download or clone the repo right from GitHub. The full instructions are there on the repo, and I'll go there in a second, like right now. So this is the repo on GitHub/Esri, Arcgis Runtime Toolkit iOS. I've actually contributed to a couple of these components. I did update the README on, I think, Friday last week. Requirements, instructions for CocoaPod and doing it manually, additional resources, issues. If you find a bug, submit an issue. If you've got an idea for a new one, submit an issue. We're looking forward to that. Contributing, see the guidelines. And then licensing, it's the Apache license. Demo, so that was easy. So we're going to start with a simple mapping application. I've already added in the Arcgis framework, imported Arcgis, and I could build and run this and it would just display a simple map with the navigation vector-based map. So the first thing we need to do is, and here's the toolkit that I've downloaded. I think I downloaded the zip and just unzipped it. First thing we want to do is take the Arcgis Toolkit Xcode project and drag it into, if I can drag it into our project. This sets up a dependency so that when we build our project, it will build the toolkit. So I'm going to do that now real quick. The second thing you have to do is in the embedded libraries where you see the Arcgis framework, we want to add the Arcgis Toolkit framework. And that will allow us access to all of the components in the toolkit. So I'm just going to build again real quick. I'm going to go into my view controller, and right underneath where I import the Arcgis framework, you can see the toolkit's right there. So we're importing the Arcgis toolkit. We're going to start with the compass. First off, we're going to add a function that will add the compass. We're going to call that function. And And then I'm going to just copy and paste in some code here. First thing we're doing is creating the compass with our map view. The compass is a subclass of UI view, so all we need to do is add subview to the compass. And then the rest of these 5 lines are about setting up the auto layout constraints so that it behaves how we want when we either rotate the device or resize the device, etc. If we take a look at the compass class itself, it has a heading property which you can set, and that will set the viewpoint rotation. You can set the compass to auto hide. So if the map's rotation is 0, the compass will hide itself. When it's not 0, it will show. You can set the width and the height. And we'll just run. So you can see it, take a look at it in action. Hang on one sec. iPhone 8. There we go. I have no idea what that is. This will be a little tricky. All right, so here we have a map with our application. If I rotate the map, you can see the compass shows up. If you rotate the map back, the map will snap when it gets close to 0. And when it gets to 0, the compass will go away. The other thing you can do, I'm having all kinds of problems, there we go, is you can click on the compass and that will set the map back to 0. So you don't have to, try to get it close. All right, that's the compass. The next is the measure toolbar. Now the measure toolbar not only displays a toolbar that shows your measurements, but will also add the sketch functionality to your map. So you can sketch on the map and do other cool things. So for this one, we're going to create a variable to hold it. And I'll explain why in the next one when we get to the scale bar. Oh, I put that in the wrong spot, didn't I? Shoot. Sorry about that. There we go. All right, so just like the compass, we're going to add a function. Call that function. I'm going to paste in our code. So the other thing I want to do is instead of having a basic map, I'm going to give ourselves a little bit fancier map. So this is just a map loaded from a portal item. It has some features that we can measure. Again, the first thing we do is create the measure toolbar. It's a UI view subclass, so we add the sub view to the view. And again, add the constraints. Notice that the bottom constraint is going to be constrained to the top of the map view's attribution top bar. So this ensures that it's above the little white bar on the bottom with the Esri logo and the attribution. And it also ensures that if you expand the attribution bar, the measure toolbar will move up a corresponding amount. And then we set the toolbar to our local variable, or our variable for the class. Build and run. So here's our new map. Wait for the features to load. And our measure toolbar down here. You can see if I click on this, the measure toolbar moves up, so it's not overwritten. First thing we can do is, this is the measure polyline or measured line. So we can just sketch a line. You can see how large it is. We have undo and redo or delete. This one is the measure polygon. And you can click on the little measurement here and pick your units. So say we want square kilometers or square statute miles. I'm going to delete that. And this is the measure feature. So what we can do is tap on a feature. It will internally do an identify and get the geometry and report back how long that geometry is, if it's a line, or if it's a polygon, it will report the area. So that's all handled, the sketching, the identify, the measuring. It's all handled with, essentially these two lines of code. Makes it real easy for you to include that functionality in your app. The next thing we want to do is a scale bar. So same pattern as before. We had the function, add the function, paste in our scale bar code. And again, it's the same pattern. You have the scale bar, it takes a map view. We set up some custom properties on our scale bar and then add that as a subview to your view. This is why we needed the measure toolbar variable, because what we're going to do is anchor the bottom of the toolbar to the top of the measure toolbar, so they won't overlap. And again, so if you expand the attribute section, both the measure toolbar and the scale bar will move up, so you're not overwriting anything. And in that way, auto layout's cool for that kind of stuff. If we go in here to the scale bar and take a look, we can set the units. And all of those enums and things are up here, so you can take a look and see what they are. We have a style, we have a fill color, alternate fill color, and a bunch of other properties that you can set to customize it for how you would like. And you notice that these are IB inspectable, so that means you can do all of this in storyboard. So you can add it in the storyboard, and then on the inspector pane on the right, you can just set all of these properties how you want them. So we'll just build and run. You can see we have the measure toolbar, and on top of that there's the scale bar. As we zoom in, you can see the scale bar updates. Automatically, and automatically resizes for whatever it thinks is the best. So that, again, it's a couple lines of code, and then what type of customization you want adding. A legend. So for the legend, we're going to need an even better map than what we have there. So I'm going to get rid of that and paste in a better map. So this is a map that's stored up on a portal. So it was created in Arcgis Online, saved, and then shared to be public. And we just, with this one line, create it, display it. Again, we're going to go a legend. And then this time I'm just going to paste in a bunch of code. So what this is going to do is it's going to create a bar button item and put it up in the as a navigation in the upper title bar. When the user clicks on that button, it's going to show the legend for the current map. Legend view controller class, make legend view controller taking your map view. This could be a scene view if you wanted to. So everywhere in all of these components where it says GeoView, it can either be a map view or a scene view. We make sure we have one using the guard let, and then we just use the navigation controller and push our legend onto the map or onto the view. So there's a lot of code behind the legend view controller, but it's very seamless, very easy to implement. So here we have a map with a bunch of features, a lot more feature layers, and we just click on the legend, and you can see all of the stuff automatically here. So this will work with any map. So I just added a new map and showed the legend for it. So any map that you have, you just pass the map view to the legend view controller and then display it. So what this does is it recursively goes through all of the layers in your map and all the sub-layers and assembles this essentially table view controller. It fetches the legend infos for you so that you can display the swatches. So that is the legend. The last one we're going to look at, and we do have a few more minutes, so I'm going to, we'll take a look at that one. But I'm going to open it up in the example app. It's fairly easy to implement, but the infrastructure around it to kind of explain it and show you what's going on was just, there was a lot, and I would have ended up copying this whole example into another example, and I think for time it's just easier to show you this one. So iPhone 8, we're going to run. So this is the example app that comes with the toolkit, and you can see it's essentially the same as what I just showed you. But this is the job manager, and what the job manager allows you to do, and actually we'll go up here. So this is the job manager code, the component itself. There's some really nice documentation on the back, but essentially the job manager allows you to take long-running jobs and automatically persist them between app invocations. So if you have a long-running job, sometimes maybe you get a phone call, you have to background the app, you're doing something else, and the system decides to kill your app. At that point, without doing anything, your job is done. You're going to have to restart it. What the job manager allows you to do is serialize those jobs to disk before the app is killed, and then when the app is loaded, the job manager will reserialize those, rehydrate them, and allow you to continue the job. It will also, if you background the app, but the app doesn't get killed, it will also notify you from the background that one of your jobs has finished. There's a fair amount of code if you wanted to do that yourself. But the job manager makes it real easy. These are the Arcgis job subclasses that the job manager works with. And so we'll just jump over here and see how it works. So we're going to add a job. And what this table view and that cell displays is the status and the current updates that's happening. So you can see here the job is being delayed. We're just delaying it. Sending a request. The job has been started. And so we can background the app and restart the app, and you can see it's still going. I'm going to add and then the job finished. I'm going to add another job, and this one's going to ask me for credentials, so I'm going to have to type the credentials. So you can see we started that job. We can start another job, which is another generate GDB job. But this time we can background the app, and we can kill the app. Maybe. There we go. So now the app is killed. The job manager, however, has serialized those to disk. So when we relaunch the app, go back into the job manager, you can see our jobs are all still there, even the one that was succeeded. These two are paused. What we can do is click the play button, and that will essentially unpause and restart the jobs. So now these will continue to work, and then we'll be notified when they're done. The way this works, get this out of the way. So this first thing up top here is the table view cell, and that's the thing that displays the status and the updates. I'm not really going to go through this, but essentially it's there's an update UI function, and it gets the job, and just gets the job string, the title, and the message from the job and displays that. This is the table view controller that does most of the work. It creates the toolbar with the buttons on the bottom that you saw, registers the cell. There's a method for resuming all pause jobs. So this is the play button at the bottom when we rehydrated the app, and it reloaded all the jobs. Job manager.shared. So you can have more than one instance if you want, or you can just use the shared instance. Resume all pause jobs. We're providing a status handler and a completion handler. And these things essentially just print the status. And the completion handler, again, will let you know if there's an error or a result. You know, in your application, you would want to take action. So when the job's done, you've downloaded your geodatabase, now you can go in there and load your layers, load your map, and then display it. We click on the plus button, we're kicking off a job. And there's one of two jobs that we were doing. We were either taking a map offline, or we're generating a GDB. This is our feature service. And we're creating a geodatabase sync task. We're loading the task, generating the parameters, setting some properties on it, and generating the job for the task, registering that job with the job manager, and then starting the job. So we register it with the job manager so the job manager knows about it and can do what it's doing there in the background, and then we start the job. So as I said, the code is all up on GitHub. I'm going to stop now, so we have a little time for questions, and so Suganya can do the next one. Take the survey if you would, please. Questions? Any questions? Cool. Thank you. Yes? Oh, you're just stretching. All right. Well, if you got anything, I think we got another half hour for the showcase, so stop by. Otherwise, I'll be there tomorrow. Thank you for coming.